Welcome to Unit 2, Lesson 4 in Algebra 2. Today we're going to be taking real-world applications and then changing them into a slope-intercept form. And the first thing we do is whenever we're getting any data, okay, we need to identify the independent variable and the dependent variable. Independent variable happens first between the two things being compared, and the dependent variable occurs as a result of the independent. So understanding that distinction is really important. And again, y depends on x, therefore y is a function of x. Okay, so the first thing over here, Papa John's Pizza mails out a flyer with 2 coupons on it. One coupon for a large pizza with 1 topping is $8.99. The other for a large pizza with 5 toppings is $10.99. Well, what's independent? What's dependent? Okay, the first thing we've got is independent is a number of toppings, and dependent is price. Again, usually, okay, and don't say this as a 100% rule. Usually, price is a y function, time is a x, and so in this one we know price most likely will be a dependent variable. It depends on the number of toppings. And if you think about it, that does make sense. Okay, so let's create 2 ordered pairs from the information we got. Okay, well, we've got a 1-topping pizza for $8.99, so 1-topping pizza for $8.99. Okay, and a 5-topping pizza for $10.99. So we create the 2 ordered pairs. Okay. Again, the first thing you want to do is find the slope. I plug it in the slope formula, y2 minus y1 over x2 minus x1. Okay, so we get this. That's $2, and then we get difference of 4 toppings. We get it, and it's 1/2 or 50 cents. Okay, how do I figure out the formula for this? Well, I plug in 0.5 or 1/2 into this form, into my point slope form, which you guys did work on today. And I pick 1 point. I'll pick the first point, 1, comma, $8.99. So I put the 1 for the x, $8.99 for the y. Solve it out, and I get y equals 1/2 x plus $8.49. And that's our formula. Okay? Well, looking at point E here, it says how much does it cost for a large pizza with sausage and pepperoni? Well, sausage and pepperoni, that's 2 toppings. So I plug 2 in, okay, over here. And work it out, and we get $8.49. Okay. State the slope and describe what it means. Well, slope is 0.5 or 50 cents, and well, that's basically the price per topping. Okay. And what does the y-intercept mean? Well, what is the y-intercept? The y-intercept is 8.49, and that's the initial price without toppings. So a pizza without toppings would be just a regular cheese pizza. Okay. Moving on. Okay. So a packaging contains 2 Reese's Cups, cost 60 cents. A package containing 10 Reese's Cups costs $2.40. Well, the independent and the dependent, again, cost is usually a y variable or a dependent variable. So cost right there. The number of cups is the independent. Okay, we'll create the 2 ordered points. 2 cups, 60 cents right there. 10 cups, $2.40. Okay. Again, first thing we do is find the slope. And the slope is 0.225, okay? And plug that in as our slope. We pick either one of the 2 points. I always like picking numbers that are smaller. So I pick the 2 and the 60 cents. I put the 2 there, the 60 right there. Work it out, and I get y equals 0.225x plus 0.15. Okay? And that's our equation. Well, state the slope and describe what it means. Well, slope is basically 23 cents, right? 0.225 is basically 23. That's the price per Reese's peanut butter cup, right? Well, what's the y-intercept? Well, the y-intercept is 0.15, and that's the initial price. So what are you going to get if you don't get any Reese's Cups, right? 0 Reese's Cups. Well, that's the cost of the packaging. Okay. Next one. This is a depreciation value. Okay. So let's say a brand new car. Well, let's move it up just a little bit more. Okay. A brand new car costs $15,000. After 1 year, its value depreciates. That means it goes down to $12,400. Write a prediction equation to estimate its worth in 5 years. Well, first of all, let's go ahead and figure out what's independent, what's dependent. Again, money or cost or price is usually a dependent variable. Independent variable is the number of years. Okay. So our 2 ordered pairs are, well, how do we come up with it? The initial price, right? That's at time 0, it cost, or when you bought it brand new, That's $15,000. And that means 0 years have run off, and the value is this. After 1 year, the value is this. So those are our two ordered points. Again, first thing we do is find the slope, which is negative $6,500. And then I plug it into the point slope formula. Okay, the slope goes there. The point I'm using is the first one, 15,000 and 0. Put 0 for x, 15,000 for y. Get the formula right here. Okay, y equals negative 6,500x plus 15,000. Okay, and that's our equation. Okay, how much is the car worth in 5 years? Well, I put in 5 for x, which is the number of years. Work it out, and I get $2,000. Okay, state the slope and describe what it means. Well, the slope is negative 6,500. Well, what that means is that for every year that you own the car, the value of the car depreciates this much. Okay, state the original. I'll state what the y-intercept is. Well, y-intercept is $15,000. That's the initial value of the car at time 0. Right? 0, 15,000. Time is 0. Okay. Next part. Okay. So in this one, we get a little bit more of a complex thing. Okay. It says the following table shows the values, shows the number of thousands of women who graduated from college in years 1981 through 1988. Okay, use a graphing calculator to create a scatter plot and regression line to show the year it's related to thousands of women. Okay, so again, independent, dependent, we have to identify those. Time is usually independent variable, so the independent variable is years, okay, or time, and the dependent variable is a number of women graduating. Okay, now the best fit prediction equation came out with this, and the correlation coefficient is this. Okay, so how did we come up with this? How did I come up with this equation? We had nothing to begin with. We came up with a scatter plot. Okay, first of all, you guys will need to download this particular thing. I will give you a copy of this, the scatter plot steps. Okay, first thing it tells us to clear the memory. Okay, then we have to go to stat and edit, and we enter in all these points right here. Okay, so I did that. If I go to stat right here, stat, and I go to edit, and I went ahead and filled in all the information right there. Okay. Once you go ahead and do that, okay, you need to make sure your stat plot is on. Did that, followed all the steps on there. Okay, and the last thing that you do, second quit. Stat, okay, you go to calculate right there, and the fourth step down, which is right here, linear regression, you hit that, you enter it, okay, and we get this. Well, it tells us what our A value is. In this case, A is our slope, okay, B, right there, in our slope-intercept form is this, and this R squared number and R number, okay. These correlation coefficients tell us how confident we are that the equation that they gave us is accurate. Okay, this one says it's 97% accurate that this is a good answer. Okay, so that is fairly confident, and we round that. Okay, so using the predictor equation, which is the one I wrote from there, how many women will graduate in the year 2000? Well, I put in 2,000 over here. Work it out, I get this answer right there. Now, this is not the answer because this is in thousands of women, so we have to multiply this number by 1,000. So this is the number of women that are predicted to graduate in the year 2000. Okay. According to your prediction equation, what is the predictor number for women graduating in 1985? And I put 1985 here. Work it out, and I get this. Again, I multiply this by 1,000, and that's the answer. Okay. Now, what's the difference? Actual difference? Well, this is what my equation came up with. Okay. And in 1985, right here, that's what it should have been. Well, what's the difference between the number that they gave us and the number that we came up with using our predictor model? I just subtract it and I get this. So I'm off by 3,850 women, which is not bad because this is, again, an estimate and not the exact answer. Okay. Interpret the slope, the meaning of the slope in the equation. That says the number of women graduating each year is increasing by 7,000 or 7.14 each year. So that's a good thing. You can look at that and see that our model, the number of women graduating each year from the data, also shows that the number of women graduating is increasing. Okay, the last page for this table shows the ideal weight of a man given height. Okay, again, height is the one that's controlling, right? And then depending on what your height is, your weight changes. Okay, so as a general rule, you'd think that the taller the person, the heavier that they are, and looking at the data, that pretty much fits it. So the independent is the height, the dependent is the weight, and again, we do the same thing. Okay, we plug this data into our calculator, okay, into the stat edit mode, plug in everything, and then get the calculate and get the linear regression, and we come out with this information, same as last one. Again, this time it's 99 or 0.99. It's 0.99, 0.997. That's 99.7% confident that this equation that it gave us is accurate. Okay, so predict the weight of a man who is 71 inches. I plug in 71 into here, and I get this equation. I get 169 pounds. Okay, predict the height of a man who weighs this. Well, this one I set y equal to 190, right? And then work backwards and solve for x, and I get 75 inches. Okay. And again, if you look over here, it pretty much fits in that area. Okay, between 74 and 76 is where 190 would be. Okay. What is the difference? Well, again, we subtract the difference, and not much. This again, you're off by 0.74 pounds, and which is not very much at all. But again, look at this. It said it was 99.7% confident that this is an accurate equation, so you shouldn't be off by too much. Okay. Now the last problem that we're working on is this right here. Okay. Again, number one thing you have to do is find out which is the independent and which is the dependent. In this case, very early, okay, the independent variable is the price. The price determines the number of bushels sold. So price is the controlling factor. Price is the one that can change, and that determines the number of bushels sold. So again, this time, okay, price is the independent, and the number of bushels sold is the dependent. We do the exact same thing. We plug in the number of bushels sold, the price, and that into our calculator, into the edit mode, and then we find the linear regression of it. We get this right here. Okay. Again, state the correlation coefficient. Okay. Whether it's positive or negative, this just states which way the data is flowing. Okay. So it's not negative 81%. It's actually just 81% because you do want to take the absolute value of it. All right. And this is 81% accurate. Well, that's not too accurate, but it's the only thing we got going, so we're going to stick with that. Okay. So because if next week the market price of wheat is $3.90, how many bushels can you predict? Okay, we plug in $3.90, and we predict that we will sell that many bushels. Okay. Estimate the price of wheat when this many bushels are sold. So we plug in y equals 25,500, and we go ahead and solve for x. We work it around. Again, we're going to use this number because every number is in. We divide it by 1,000 to get these, because these are in numbers for 1,000. So move the decimal over 3 times, use this, solve for x, and we get that answer. All right. If you have any questions, please come see me, and I hope you guys had a good day.